All right, let's look at the homework 7.8, problem number 8. All right, so we have this double integral, and we want to find the region R. All right, so here. All right, so let's look at this lower limit and upper limit. So it's y equals square root of x. So this would be the curve right here. Y equals square root of x. All right, so that's the lower limit. All right, so it's going to go up to y equals 3, which is a horizontal line. So you can see that this is not going to be it. And here you don't have a square root of x, which should look like that. So this is not it. All right, and here you have a square root of x and 3. So this is going to be the right picture. All right, this is not the right picture because this curve, it looks more like x squared. All right, so this is going to be the answer. All right, let's check the answer first. All right, I came back and looks like we got the picture correctly. All right. All right, so it says that change the order of integration and show that the both orders yield the same area. All right, so let's do that here. All right, so this is the picture, right? And actually, I didn't want to keep that one here. All right, so we have that. All right, then what we need to do is we want to change the order of integration. So this is going to be equal to, all right, and so this is going to be an integral, all right. Then what you need to do is you have to take the antiderivative integral with respect to x first. Then we take the antiderivative with respect to y, all right. So what you want to do is you basically fix the y value first. So I'll just pick a random y value, right? Then you can see that the x value starts from 0. So this is right here, x equals 0, right? Which is this vertical line here, right? This is going to go all the way up to this curve right here, right? So this curve has an equation y equals square root of x. But since we want x equals form, so we can just square both sides. So we have a y squared is equal to x. Well, maybe I should write it as x equals y squared. Right? Right. So you can see that the x value is going to go from 0 to y squared. So we have 0 here, and then you put y squared, right? Then y value, to cover the entire region, you're going to have to start from y equals 0. Then, keep on covering, all these, and keep on doing that. And the last place is here. Y value is equal to 3 there. So we know that this y is going to go from 0 to 3. Right? Let's evaluate the value. Actually, we're going to just type in. Right? So we know that it's a 0 to y squared. And then that's going to be 3. Right? Then we just have to find the value. We need to, I'm too lazy to do both of them. I'll just do one of them, and the answer is going to be exactly the same with the other one. So here, what I'm going to do is, leave the outer integral alone for now. So we have that. So antiderivative 1 with respect to x is x. So we have a x, and then going from 0 to y squared. Right? Then you plug in the top number first, so at y squared, so it's going to be y squared, minus 0, so I'm not going to write that, so you have dy. Alright, antiderivative y squared would be add 1 to the power, divided by 3, just the power rule, and then going from 0 to 3. Alright, if you plug in 3, 3 cubed is 27, divided by 3 is 9, minus plug in 0, so it's a 9 is the answer. Alright, let's type it in. Alright, so we got 9. Alright, let's check the answer. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.